Now here, how the N-type and P-type semiconductors are forming, we are going to discuss here. See, I am taking here silicon. Silicon has valence electrons, 4 valence electrons. So it is forming like this structure. Now this silicon is doped by 15th group element. 15th group element, suppose phosphorus is there. This phosphorus is doping, means phosphorus adding here a smaller amount, that is called doping. Doping means the smaller amount of impurity is adding to the main substance, that is called doping. Even you heard about this word. Athletes also, they are taking some drugs, that is also comes under doping only. Now this silicon is replaced by phosphorus. Suppose phosphorus has 5 electrons, so 4 electrons are involving in the bond, so 1 electron is extra, and one more, suppose here also one phosphorus is replaced, then here also 4 electrons involving and 1 electron extra is there. So finally conclusion kya hai? Electrons are excess. Whenever this electron rich or electron excess conductor, semiconductor is known as N-type semiconductor. This is N-type. This is N-type semiconductor. Here electrons are rich. Electrons rich. Suppose this silicon is doped by 13th group element. 13th group element, either it may be boron or aluminium. See here, nitrogen we cannot take. Nitrogen we cannot take. Phosphorus and arsenic you can take. So here boron, aluminium, both are solids, we can take. So suppose I am taking boron here. Boron. Boron has only 3 valence electrons. So here valence electron 1, another electron, 3 electron. Here empty space. Okay, 4 electrons tha silicon ka, lekin silicon is replaced by boron. But boron came with only 3 electron. So 1 electron deficient is there. So 1 hole created. Then again here also one boron is substituted. So 3 electrons are there. 3 electrons. Here also one hole is there. So like this here, holes are rich. Holes, empty spaces are creating. Then this type of semiconductor is known as P-type semiconductor. P-type semiconductor. Okay. Then whenever we are keeping electric field, here plus anode and here cathode is there. These holes, empty holes, these holes are moving towards negative charge. That means cathode side jata hai. Here electrons are there. Suppose here you are keeping anode and here cathode is there, minus charge. Obviously this electron is moving towards positive anode side. So due to this electron movement here, these are acting as conductors. Here due to holes movement, these are acting as conductors. Of course sir, already silicon is a semiconductor. Why we are using this? Silicon is naturally semiconductor, but it has fixed value. If you want little bit more or higher, little different values, then you have to dope. By doping the quantity of this boron and phosphorus, you will get the semiconductor the conductivity will be vary. How much you want, you can make different types of semiconductors, we can make it. So what is the use of this semiconductor? See here, one is N-type and P-type. So these N-type and P-type semiconductors are more useful in the computers and in the photoelectric diodes. We know that solar energy is there. In that solar energy, how the solar energy is creating means these diodes are very, very important. Here mainly 2 types of diode. One is PN diode, another one is NP diode. PN and NP diodes. Generally PN, small n, PN diode and NP diode. Then furtherly we can make into transistor, PNP transistor, PNP transistor and NPN transistor. PNP and NPN transistors. We know that transistors we can use for alternative current into direct current, AC to DC, as well. These transistors are used in the radios and TV, okay, to pass the signals, convert into electric signal into different. So these transistors have bigger role in the media, okay, as well in the electronic, digital, all digital things, even computer, mobile and everything, TV. So these are the general things. As well, other than this 14, 15, 13th group, we can make some more diodes. The other than 14th group elements, other than 14th group, silicon, germanium, other than 14th group elements, we can make semiconductors by 12th and 16th group elements also. 12th and 16th group. What are the 12th group elements? Zinc, cadmium, mercury and oxygen, sulfur, selenium, tellurium and polonium. Oxygen is the gas, polonium is the radioactive element, we cannot use. Then zinc sulfide we can use, zinc sulfide, cadmium sulfide, even cadmium selenide, okay, mercury selenide. So these are also acting as a semiconductors. The useful is already we discussed in the digital as well as in the medical also we can use these diodes. In the heart operations also they are using. Then other than this, some transition metal oxides में titanium oxide, chromium dioxide, rhenium oxide, these are acting as metals like copper, aluminum जैसा, almost metals जैसा act करते, good conductors we can say. Then vanadium oxide, dioxide, vanadium trioxide and titanium trioxide, these are acting as conductors as well as insulator. दोनों कैसे? Insulator. So we discussed already conductors. By increasing the temperature, the conductivity will be decreased. While temperature is increasing, conductivity will be decreased. So up to certain temperature, these are acting as a conductor. After certain temperature, these are acting as an insulator also. Okay, this is important point here. Titanium oxide, chromium dioxide, rhenium trioxide, these are acting as a like metals. Vanadium, almost all oxides, monoxide, dioxide, trioxide, including titanium trioxide, these are acting as a conductor as well as insulator. Depends on the temperature. Okay, these are the conductivity properties of metals in the solid state chapter. The next video you can see magnetic properties. The topic is over. You can practice the questions, ask doubts.